Alright, this is our first lesson on prisms, pyramids, cylinders, cones, and spheres. And I abbreviated that PPCCS. So put your heading just like I have it. Alright, this is page 1 out of 2. And this is what the title of the lesson in the video will be. Alright, and then you can skip a line and put down the heading of the unit. Okay, skip another line, put down number 1. Prisms. Okay, that's what we're talking about in this lesson. We're going to talk about prisms. That's what this whole lesson is going to be about. The rest of these things we're going to cover in future lessons. Okay, so there's a few critical concepts that we need to talk about when we're dealing with prisms. All right, here's the first one. We need to know and apply that the lateral edges of a prism are congruent and parallel. And we'll see exactly what a prism is and what the lateral edges means. Okay? The second thing, B, is we have to know and apply that two prisms have equal volumes if their bases have equal areas and their altitudes are equal. Alright? And altitude is another word for height. And the last thing, the last most important concept, is that we need to know and apply that the volume of a prism is the product of the area of the base and the altitude, also known as the height. Okay? So, let's go down to our first statement about prisms. Prisms are three-dimensional closed surfaces. Okay? And here's some examples of what prisms look like. Alright, you're going to draw these the best that you can. Okay, we're not all great artists, but you draw them the best that you can. So this first one on the left is called a right triangular prism. And you can see it's called a triangular prism because the bases, these are the bases, they're triangles. Okay? And when you have rectangles as these sides are called the lateral faces. When the lateral faces are rectangles, it's called a right prism. So this is a right triangular prism. Alright, because it's got triangles as bases and rectangles as lateral faces. And there's one on the left, one on the right, and there's also one in the back. Okay? And then look at this. This is a right rectangular prism. So in this one, the base, we could think of the base as the front and also the back. Okay, and those are rectangles. And then the sides, all of the top and bottom and the sides are lateral faces. And they're also rectangles. So this is a right rectangular prism. And when you look at this, you can see that this is slanted, right? So this is a triangular prism. But because it's slanted like this, it's called an oblique triangular prism. Okay, these lateral faces are not rectangles, they're actually parallelograms. Okay? So this is an oblique triangular prism. So these are just examples of what prisms look like. You can imagine taking two shapes like two triangles and stretching them out. Alright, that's a prism. Or taking two rectangles and stretching them out. Alright, that's what prisms are. So let's turn this over and look at two more examples of what prisms are. And you're going to draw these two examples. This is a parallelepiped. Alright, this is a special type of prism where the bases, like this front and the back base, are parallelograms, and all of the lateral faces are also parallelograms. And this one on the right is called a right pentagonal prism, because you see there's two pentagons. Right? There's one in the front and one in the back. And you can imagine taking those pentagons and stretching them out. Okay? And you have lateral faces. You have 1, 2, 3, 4, 5 lateral faces that are rectangles. That's why this is a right pentagonal prism. So those are 5 examples of what prisms look like. Now let's learn more about their properties. Alright? First of all, a cube is a regular prism. Alright, that means cube is something you're very familiar with. All of its sides are the same length, so that's called a regular prism. Okay? It's like taking two squares and stretching it out. Alright? Alright, now this is very important. A prism has two parallel faces called bases okay, that are congruent polygons. Those are the things, the bases are the two shapes that you hold and that you stretch from. Like for a triangular prism, the triangles are the congruent polygons. They're congruent and we stretch them out to form a prism. So it has two parallel faces called the bases that are congruent polygons. The lateral faces are rectangles in a right prism or parallelograms in an oblique prism. In a right prism, the joining edges and faces are perpendicular to the base faces. So let's look at some examples, all right, of what this means. Let's just cover this one up for now and look at just the one on the left. Okay? So this is our triangular prism, right? These triangles, the things that we stretched out, and it doesn't matter if this thing, see this thing is standing up tall, but it could also be laying down. All right, what matters is those triangles are the bases, and we're taking those bases and stretching them out like there's rubber bands connecting them. Okay? And those rubber bands are these sides right here. All right? So the triangles are called the bases. The height of this thing is called its altitude or its height. All right? And these other faces are called its lateral faces. Okay, so we're just getting an idea of how we name the different parts of a prism. Let's look at this. This is like a rectangular prism, or even it could be a cube, right? So if we chose the top and the bottom to be our base, all right, those would be rectangles. The height, now imagine this thing is sitting on a table. The height is from the top to the bottom, all right? If this thing was laying on its side, then we can say the height was from left to right. So it doesn't really matter, okay? Remember that height is the altitude. So whatever is not the base, all the other sides of this shape are the lateral faces. Okay? Now, here's a triangular prism, but this time it's not standing up, right? Well, it's kind of like laying down a little bit more, right? It's like, you could imagine this thing is laying down on your page, and like the triangle's coming up. So the triangles are still the bases, okay, no matter how this thing is shaped. And these three sides would be the lateral faces. And so this thing is actually standing up and it's tilted, all right? This is an oblique triangular prism. So the height goes from the top to the floor, straight down, okay? It doesn't follow along the side. If this thing is leaning, the height is from the top straight down. That's the altitude. Imagine standing on this corner and dropping a weight down. It wouldn't go in a slanted direction. It would go straight down. All right, that's the height. So we have bases, lateral faces, and the height, or the altitude. All right, let's go to the next page. All right, this is the second page. Let's put 2 out of 2. This is another really important concept. Put your heading, okay? The edges of the prism where the lateral faces intersect are called its lateral edges. The lateral edges in a prism are congruent and parallel. This is extremely important. They always ask questions about this on the Regents. Okay? Here's an example. This is a right pentagonal prism, right? We took 2 pentagons and we stretched them out. So the pentagons are the bases, and these rectangles, these 5 rectangles, are the lateral faces. Now these lines that connect the 2 pentagons, there's 1, 2, 3, 4, 5 of them, they're called the lateral edges. Okay? And they're all congruent to each other, that's why they have the 1 hash mark, and they're also all parallel to each other, that's why they all have 1 arrow on them. Okay, or a feather mark. So they're all congruent and they're all parallel. That's what this said. Let's keep going. Let's move this up. So the volume of a prism is the product of the base area times the height. Okay? So volume is B, big capital B, times H. And B is the base area. It's the area of the base. Okay? So let's see how this looks in a diagram. So remember, V is the volume, B is the area of the base. So look in our diagram. This is a triangular prism, right? We took two triangles and stretched them. So these triangles are the bases. This capital B is the area of one of the bases. All right, because in a prism, the bases are always the same shape. They're always congruent. We just need to find the area of one base. So in this case, it would be the area of a triangle. That's what B is. And then we multiply it times H. Now, since this thing is laying on its side, our H is going in this direction. H is always the distance between the two bases. All right, it's the distance of the lateral edge, right? So it's the area times the height. And this thing was two triangles that were stretched out, okay? We want to know how much space is inside. That's the volume. So that's it for this page. Now turn it over and we'll talk about a couple more things. Okay, surface area. The surface area of a prism is the sum of the areas of the bases plus the areas of the lateral faces. So this simply means the sum of the areas of all the faces. So we have to find the area of every single shape of the prism, and we have to add them all up. Okay? So let's see an example of what this might look like. You see this triangular prism, right? The bases are the triangles. We took those two triangles and we stretched them out. So what you have to do is imagine unfolding this prism. So if we took, there's two faces, there's one face on the bottom, right? And there's two faces that go diagonally up. Now you have to imagine unfolding those. So you would have the base rectangle and the two faces are also rectangles on the side. So these are three rectangles. And they represent this side, the other side over here, and the bottom rectangle. There are three rectangles. And then imagine taking the two triangles and dropping them down like this. So this one right here, if we flattened it out, would be this one. And if we took this front one and flattened it down, it would be this one. So if you can imagine this was a model and we unfolded it, this is what it would look like. And to find out the surface area, all right, all we do is we add up all the areas. So we would do A1 plus A2 plus A3 plus A4 plus A5. All right. So that's the surface area. You just add up all of the areas. Okay. Now volume, the difference between volume and surface area, imagine volume is like this cup that's filled with water. Volume wants to know, like, how much water can we fill up a cup with? Surface area is, if I wanted to paint this glass black, all right, how much paint would I need to cover all of the surfaces of this cup? That's surface area. It's just like wrapping this with wrapping paper or painting it. Volume is how much can you fit inside of the thing. Okay, so that's the big difference. Let's keep going. So here's just two formulas you need to remember from basically middle school and elementary school, all right, and also algebra. So in order to add up all these areas, you're going to need to know the area of a rectangle and a triangle. So in case you forgot, the area of a triangle is 1/2 times the base times the height, and the area of a rectangle is base times height, or length times width, whatever you want to call it. It's one side times the side that's next to it. Okay? Let's keep going. This is another one of those important concepts that we talked about at the beginning. Two prisms will have equal volumes if their bases have equal areas and their altitudes or heights are equal. Okay? So two prisms will have equal volumes if their bases have equal areas and their altitudes or heights are equal. So let's take a look at what this might look like. Okay? And this is the last part of the notes. So here we have two different prisms, right? We have this triangular prism where we took two triangles and we spread them apart. That's this one. And then this one we have two rectangles that we took and we spread those apart. So we have two completely different prisms. But there's something very interesting about the volumes of these prisms. If the area of the base of this prism, which is a triangle, is equal to the area of the base of this prism, which is a rectangle, and the heights are the same, then the volumes are the same. That means that if their base areas and if their heights are the same, we could fill these things with the same amount of water or sand or whatever you want to imagine putting in there to fill it up. You would be able to put the exact same amount in each one if their base areas are equal and if their heights are equal. So that's what this says. If A1 equals A2, that means if their base areas are equal, and H1 equals H2, their heights are equal, these two prisms will have the same volume. Okay? Now let's look at the problems that we can solve involving prisms. Okay? So, this is, let me see, this is page 1 out of 3. Actually, you can make this page, 1 out of 3. These are the examples. And this is the first out of 3 pages. Okay? Put your name at the top. So look at this first problem. The figure in the diagram below is a triangular prism. We took two triangles and we spread them apart. All right? This one's laying on its side. It doesn't matter though. Which statement must be true? Okay? DE congruent to AB. So here's DE right here. And here's AB. No, those don't have to be congruent. AD congruent to BC. Here's AD. And here's BC. No, those don't have to be congruent. Nothing we learned said that. AD is parallel to CE. Here's AD. And here's CE. Remember that these are lateral edges. And lateral edges are always parallel and also congruent. So our answer then is choice 3, which says that AD is parallel to CE. All right? And you can look at 4 just to see DE. DE is this line here, and they're saying that's parallel to BC. No, those are definitely not parallel, right? One's leaning this way, one's leaning this way, and one of them is leaning in a different way like that. So those are definitely not parallel. Let's look at number 2. The diagram below shows a right pentagonal prism. So you see the pentagons, that's why it's pentagonal. So we took 2 pentagons and we stretched them out. All right, and this thing is standing on its on one of the pentagons. It's standing straight up. So which statement is always true? You see, this is going to be another one of these type questions about the lateral edges. You see how they ask this a lot? Remember, these are the lateral edges, and we know that they're all parallel. And we also know that they're all congruent. So let's see if one of these choices has to do with that, because I can almost guarantee you it does. BC parallel to ED. BC and ED, you can tell they're not parallel. Okay? FG parallel to CD. FG is right here. CD is right here. They look almost parallel, all right, but they're not. And even if they were, you wouldn't know that because we didn't learn anything that said anything about the sides of the bases. We learned about the lateral edges, okay? FJ parallel to IH. Here's FJ, and here's IH. Those are obviously not parallel. And then GB parallel to HC. Here's GB. That's one of the lateral edges. And now where's HC? Here it is. That's another lateral edge. They're parallel and they're congruent. So it's choice 4. Let's look at number 3. The diagram below shows a rectangular prism. Which pair of edges are segments of lines that are coplanar? All right, so this is a little review actually. Okay, this really doesn't have to do with prisms too much, but it is a rectangular prism shape. But this is testing our knowledge of coplanar. That means on the same plane. Remember, each one of these faces is a plane. So when you're talking about a rectangular prism, you have a front and a back, a top and a bottom, a right and a left. So you have 6 planes. So which pair of edges are segments of lines that are coplanar? So which lines are on the same plane? AB and DH. Well, here's AB and here's DH. Those aren't on the same plane, right? One of them is on the top plane and on the left plane, and DH is on the front and right plane. AE and DC. AE is here, that's on the left and back plane, and DC is up here, so those are definitely not on the same plane. BC and EH, here's BC up here, and here's EH down here. No, those are opposite each other, they're not on the same plane. CG and EF. Here's CG, okay. CG and EF. No, those aren't on the same plane either. So we must have missed. Whoop, let me get an eraser. CG. Nope. Those are not on the same plane. So I think we skipped the right answer. Let's go back to 3. BC and EH. Where's EH? Okay, EH, no, EH is on the back and BC is on the front, or depending on how you're looking at it, the back. So it's not that. AE and DC, it's not that. AB and DH, it's not that one. AB, DH, AE, and DC, BC, and EH, BC, it's not that, CG, and EF. None of those choices are correct, unless I'm seeing things. Let's say CG and EF. Let's instead say this was CG and DH. Okay? DH and CG, those are on the same plane, right? They're on this right plane. So let's say choice 4. Okay, and number 4. The diagram below represents a rectangular solid. Which statement must be true? Okay, EH and BC are coplanar. EH and BC are not coplanar. Okay, so that's not true. FG and AB are coplanar. FG and AB are not coplanar. EH and AD, EH and AD are not skew, they're parallel, right? EH and AD are parallel. Remember, skew means like this. They're not crossing, they're going in different directions. If they were going in the same direction, they would be parallel. Once you turn one of them and like raise it in the air, then it's called skew. Alright, and we did talk about that at the beginning of the year. So let's see, FG and CG, that's going to be the answer right there. FG and CG are skew lines. Okay. Let me just check the other ones again. EH and BC. No, those are not coplanar. FG and AB are not coplanar. EH and AD, those are parallel. It's choice 4 then. Okay, let's turn this sheet over. Get into some more involved problems now. Put your name on the top. Tim has a rectangular prism with a length of 10 centimeters, a width of 2 centimeters, and an unknown height. So I'm going to draw this one laying down. Alright, it's a rectangular prism. Okay, and then this is not that easy to draw. It definitely takes some practice. Okay, so here's my front. Here's my front base. That's the front rectangle, and here's the back rectangle. Okay, you got to be careful the way you look at this, because all of a sudden this looks like the front, and then it switches and looks like the back, and then the front and the back. So you got to pick one way. Those dotted lines here mean that this is my front. So you have to try to keep looking at this until this face pops out at you, and this face is in the back. All right. So we took two rectangles and we spread them out like that. So it has a length of 10 centimeters. So the rectangle's length is 10. And it's got a width of 2, so even though you may think this is the height, remember the height is the distance from one base to the other base. So this is my height, which is unknown. All right, if I were to draw this thing standing up, all right, then the height would have been standing up, but I wanted to draw it laying down. So now my width is 2 centimeters. He needs to build another rectangular prism with a length of 5 centimeters and the same height as the original prism. The volume of the two prisms will be the same. Find the width in centimeters of the new prism. So let's just think about the volume of this one first. Let's call this one the first one. Okay? The volume equals the base area times the height. Now, the area of a rectangle is base times height. So in this case, the area is 10 times 2. The area is 20. And that's centimeters squared. So remember, B is our base area, so this is our B here. So volume equals 20 times H. And the H we don't know yet. All right? It was unknown. But now we do know that he wants to build another box, another rectangular box. Okay? So this is our front, and this is our back. He wants to build another rectangular prism with a length of 5, so this time he wants the length to be 5, the same height as the other one. So we don't know it yet, but it's the same, so it's H, because the other one was H, so this one is H. And let's see, he needs to build another rectangular prism with a length of 5 centimeters and the same height as the original. The volume of the two prisms will be the same. Find the width in centimeters of the new prism. So we don't know the width. Let's make that a W. Let's call this shape 2. So for shape 2, it's the same formula. Volume equals base times height, the base area. So for this one, it's the same thing. Base area of rectangle. A equals BH, or length times width, base times height, it doesn't matter what you call it. So the base is 5, and the height, or the width in this problem, remember it's the area of this rectangle, so don't get confused with this height. It's a little confusing because sometimes people use base times height for the area, sometimes they use length times width, but it doesn't matter. It's one side of the rectangle times the adjacent side of the rectangle. Okay, so it's 5 times W. So the area is 5W. So here we have volume equals 5WH. The base area is 5W and the height is H. We don't know it. Okay. Find the width in centimeters of the new prism. So he says the volume of the two prisms will be the same. So this V and this V have to be equal to each other. So V must equal V. Let's say actually V1 must equal V2. V1 is 20H, and that must equal V2, which is 5WH. And we have to solve for W. So we subtract both sides by 5H. These 5's cancel and these H's cancel, and we're left with W equals, these H's cancel, and we're left with 4, and that's centimeters. Okay? So that was a pretty challenging problem, right? You can see these can get tricky, especially when you start getting confused with your heights and your widths and your bases. You really have to remember that this capital B is just the area of one of the bases. One side times its adjacent side for a rectangle. Let's look at number 6. A rectangular prism has a volume of 3x squared plus 18x plus 24. Its base has a length of x plus 2 and a width of 3. Which expression represents the height of the prism? So let's just draw a picture. Alright, and this so our base is x plus 2 and our width is 3 and our height we don't know. Right? But we do know that if we multiply the area of this base, so we know that the volume equals base times height, base area times the height. So the base area of a rectangle is base times height, and in our case it's x plus 2, 3 times x plus 2. Again, don't confuse this h with this h. They're two different h's. Alright, this h is this h, okay, but in this area formula this h is this width or this dimension here. So the volume is 3x squared plus 18x plus 24, and that's equal to 3 times x plus 2 times h. So we have to factor this left side. So let's do that over here. 3. This will be a really good review since you guys haven't done this since algebra. 3x squared plus 18x plus 24. First you got to pull out the greatest common factor. So I'm pulling out a 3. And I'm left with x squared plus 6x plus 8. Right? I divide everything by 3. So that if I had to multiply this 3 back into everything, distribute it, it would give me back 3x squared plus 18x plus 24. Right? 3 times x is x squared, 3 times 6x is 18x, 3 times 8 is 24. So it checks. Now I have to break this down. 3 into x something, x something. Right? You remember this? We're factoring this trinomial. It's trinomial factorization. So we have to think of all of the factors of positive 8, and we have to think of which ones add up to positive 6. So 1 and 8 are factors of 8, but they don't add up to 6. But 4 and 2 do add up to 6. Right? So positive 4 and positive 2, if you multiply them, you get 8. If you add them, you get 6. So those are our two factors. So let's plug that back in over here. On the left side we have 3 times x plus 2 times x plus 4 equals 3 times x plus 2 times h. Now if we want to find h, we got to divide both sides by 3 times x plus 2. And watch what happens. 3 cancels with 3, x plus 2 cancels with x plus 2, and we're left with x plus 4 equals, this 3 cancels with that 3, this x plus 2 cancels with that x plus 2, and we're left with h. So which expression represents the height of the prism? H equals x plus 4. Here's your answer. Another tough problem, right? Because you had to remember all this stuff. If you didn't understand what I just did when I factored, then you really need to stay for extra help, because we're not going to be going over this in class except for, if we do another problem like this, and this is something you have to know from last year. So if you don't remember this, you really need to stay after for extra help and ask me how to do it. Okay? So let's go to page 2 out of 3. Put your name at the top, and we're on number 7. A packing carton in the shape of a triangular prism. So you see the 2 triangles, and we stretched them out. So this is a triangular prism. It's shown in the diagram. What is the volume in cubic inches of this carton? Remember, volume equals base area times height. This time the base area of a triangle is 1/2 base times height. That would be 1/2 times the base is 6 times the height, or the altitude, is 4. They gave us everything we needed. So area equals 1/2 times 6 is 3. 3 times 4 is 12. And that's 12 inches squared. You just see something? Let's just go back. No, we're good. So, now we can plug that back in. Volume equals, this is our base area, so 12 times our h is the distance of the lateral edge. It's how much we stretch these 2 bases apart. We stretch them apart by 10. So the volume equals 120 inches cubed. Alright, remember, area is squared, volume is cubed. Okay? So here's our answer, 120. Let's look at the next one. The volume of a rectangular prism is 144 cubic inches. The height of the prism is 8 inches. Which measurements in inches could be the dimensions of the base? So they tell us it's a rectangular prism, right? So the volume equals B times H. They say the volume is 144, and that equals B times the height, which is 8. So if we divide both sides by 8, our base area must be, 8 goes into 14 once, and 8 times 1 is 8, and 14 minus 8 is 6. Bring down the 4, we have 64. 8 goes into 64 8 times. Okay? So our base area is 18. So we have to see which one of these, remember, so the base area of a rectangle, right? This is a rectangular prism, is base times height. So we have to see which one of these will give us 18 for the base area. And let's see, 9 times 9, that would be 81. 12 times 8, that would be 96. 2.5 times 7.2, I'm taking out my calculator. I'm going to be lazy. Okay. Is 18. There it is. Now let's just check what the other one will be. 3.3 times 5.5. 18.15. I wonder how many people got 18.15 and said, oh, that rounds to 18, that must be the answer. That's probably why they put that choice there, but no, it's not it. It's choice 2, 2.5 by 7.2. Turn this page over. Let's look at number 9. Put your name at the top. The Parkside Packing Company needs a rectangular shipping box. The box must have a length of 11 inches and a width of 8 inches. So I'm just going to draw a quick picture. Alright, so if this is our front, this is our rectangular box, right? And then we stretch it out. And we have our other rectangle in the back. Right there. So if you wanted to put stuff in this box, you could put it in the top, right? You could drop things into that box. This is the bottom down here. This is the right side, the left side, and then the top. So the length is 11 inches, and the width is 8 inches, and our height, we don't know. We want to find to the nearest tenth of an inch the minimum height of the box such that the volume is at least 800 cubic inches. So volume is base area times height. The base area of a rectangle is base times height, or length times width, it doesn't matter. So it's 11 times 8, so it's 88 inches squared. That's our B. So volume, now if they're saying it must be at least 800 cubic inches, 800 is our volume, and so our base area times our height must be greater than or equal to. So I'm saying this side must be greater or equal to 800. Okay, it must have a volume of greater or equal to 800. So I'm reading from right to left. All right. So it's 88 times H. Whatever 88 times H is, it must be greater or equal to 800 because it has to have a volume of at least 800. Okay. You could always flip this around and make it 88H greater than or equal to 800, but it doesn't matter. If I read this right to left, as long as I draw this sign correctly, 88 times H is greater or equal to 800. That's fine. Divide by 88. So H must be greater or equal to 800 divided by 88. Rounded to the nearest tenth, it's 9.1 inches. That's the answer. H must be greater than or equal to 9.1 inches. So you can write it this way, or we could flip it around if that makes you more comfortable. It means the same exact thing. H greater or equal to 9.1 inches. H greater or equal to 9.1 inches. Okay? Number 10. This figure represents a slab of cheese. It is in the form of a right triangular prism. So there was a triangle on the ground and we stretched it up. Alright, so the bases are here and here. They're the triangles. Okay? It is in the form of a right triangular prism. Find the least amount of wrapping needed to cover the cheese on all sides. Okay. So, let's see. What I have is two triangles in the top and bottom, and those triangles are congruent, right? So, let's do this one step at a time. What we're doing right now is the surface area. because you needed to wrap. And when you're wrapping something, you're not filling it, okay? You're covering its surfaces, right? So we need to find all the areas of all the shapes in this figure. So let's find the area of triangle 1. Area equals 1/2 base times height. Now, the base of this triangle, now if you're looking at the triangle like this, right? This is the height, and this is my base. So it's 3 times 4. It's 1/2 times 3 times 4. So the area, if I do 1/2 times 4, that's 2, and 2 times 3 is 6. The area is 6 inches squared. Now, the area of triangle 2 we don't need to solve for because these two triangles are exactly the same. They're congruent. All right, and that's always the case in a prism. The bases are always congruent. So this is also 6 inches squared. Okay? Now let's try to figure out this back rectangle. Right? This rectangle back here. And let's call that the area of rectangle 1. Area is base times height. Area equals 2 times 3. Area equals 6 inches. And now let's look at this. Let's say this one. Let's look at this rectangle over here. Right, this one that goes all up here, which is 4 by 2, right? If this side is 2, so is this side. So let me put a little 2 inches there. 4 by 2. So area of rectangle 2, base times height, 4 times 2, 8 inches squared. Area is always squared, so fix that one to 6 inches squared. And then our final one is this one in the front, right? This big rectangle in the front here. So let's call that area of rectangle 3. And ooh, look at that. They don't give us this side, right? They do not give us this side. But we can find that side, okay? If I take one of these triangles, all right, say I took this triangle right here, all right, and I'm going to take it and I'm going to redraw it standing up like this. Okay? So, if I took it and I just rotated it this way, my base is 3 and my side here is 4. So this is 3 inches and this is 4 inches. Now this is a right triangle. Okay? I can find my hypotenuse. Let's call it x. Right? A squared plus b squared equals c squared. So 4 squared plus 3 squared equals x squared. 16 plus 9 equals x squared. 25 equals x squared. So if I take the square root of both sides, that square root cancels out the squared and I get x equals the square root of 25, and the square root of 25 is 5. So this is a 3, 4, 5 triangle. So now I know that my hypotenuse is 5 inches. This one and also this one down here. So that was a little tricky. So now the area of this rectangle in the front is base times height, 5 times 2, or length times width, whatever you want to call it. Area equals 10 inches squared. So now finally, surface area is 6 plus, we just add up all the areas, plus 6 plus 6. So let's circle these areas that we found, because these are like partial answers. So 6 plus 6 plus 6 plus 8 plus 10. 6 and 6 is 12, plus 6 is 18, plus 8 is 26, plus 10 is 36, and that's inches squared. And we'll box that one because that's our final answer. Okay, so you can see these problems take a little while, but if you just take your time, they're not hard, and they're usually worth a lot of points. And these are the easiest ones that you can really get for the ones that are long problems where you have to show all your work, because these concepts are very simple. It's just taking your time and making sure that you do everything and check it all over many times. Okay, so let's go to the third page. Let's put 3 out of 3. Put your name. Okay, find the volume in cubic feet. Now what we have here is a trapezoid. Okay, this is a trapezoidal, a right trapezoidal prism. There's a trapezoid in the front and there's one in the back. Okay, and you don't know the area, or you might not remember the area of a trapezoid. The area equals 1/2 the height times base 1 plus base 2. Okay? And the bases are the parallel sides. So the bases are these edges. This side is parallel to this side. Okay? So let's see how to work this out. Area equals 1/2 times, now the height is the other side, is the distance between the two bases is the height. So 25 times 9 plus this height is the same as this height, 9 plus 16. So area is 1/2 times 25 times 25. Now, I believe 25 times 25 is 600. No, 625, and then we got to multiply that by 1/2, 312.5. And that's feet squared. Now, that's the base area of a trapezoid. So we're going to need that for the volume formula, which is base area times the height, right? So volume equals 312.5 times, now the height is the distance between the two trapezoids. There's one in the front and one in the back. So the height is this 18 here when we're talking about this formula. So times 18. So 312.5 times 18 is 5625, and that's feet cubed. Okay? Number 12. Pine bark mulch 6 inches deep is to be spread in each of the beds shown below. So we have 1, 2, 3, 4 beds. One's a circle and 3 are rectangles. And they each have to be 6 inches deep. Mulch is sold in bags containing 1 cubic yard. How many bags of mulch will need to be purchased? So 6 inches is 1/2 of a foot. So my depth, right? My depth on these prisms, my height is 0.5 feet. And that goes for all of these objects, okay? So let's call this one 1, this one 2, this one 3, and this one 4. So I got the volume of 1 is base area times height. Now my base area is base times height. So that's 25 times 2. It's So that's 50. So V1 is 50 times 0.5, right? Because that's my height of this prism. So that is going to be 50 times 0.5 is 25, and that's feet cubed. Now let's do V2, which is also base times height. I'm going to solve for my base area. Well, it's the same thing, right? So we don't even need to show this extra work because it's the same exact shape. 2 by 25. So this is also 25 feet cubed. Now V3 is a little different. It's bigger. So we have to show the work for this one. Base equals little base times height. So the base area is 4 times 25. That's 100. So volume 3 is 100 times 0.5, right? Because this one also goes 0.5, and so does this one. Okay. So the volume of number 3 is 50 feet cubed. So we have some partial answers here. Let's circle them before we start getting confused. So we figured out the volume of this one, this one, this one, and now we need this one. So you can imagine that this thing is also right, the distance here is 0.5. So volume of 4 is base area times height. Now this is a circle, okay? That's pi r squared. The area of a circle is pi r squared. So this would be pi. Now the diameter is 15. So the radius is 7.5. Radius equals diameter over 2. Radius equals 15 over 2. Radius equals 7.5. So this is pi times 7.5 squared, which is, I'm going to leave it as, well, I'm going to actually, not going to leave it. I'm going to use pi in my calculator. We have 7.5 squared times pi. That's about 176.7 feet cubed. Okay, so let's see. Let's add up our volumes. So our volume is 25 plus 25 plus 50 plus 176.7. So our volume is 276.7. It's approximately 276.7 feet cubed. Now the bags are in cubic yards, and 1 yard cubed equals, now you have to remember, a yard cubed is, now 1 yard equals 3 feet. So 1 yard cubed, 1 yard by 1 yard by 1 yard is equal to, if we converted that to feet, 3 feet, 3 feet, 3 feet. So 1 yard cubed, 1 times 1 times 1 is equal to 3 times 3 times 3. That's 9 times 3. That's 27 feet cubed. Okay? So if we want to know how many bags, because one bag is 1 yard cubed, which is also 27 feet cubed, then we have to divide 276.7 feet cubed divided by 27 feet cubed. You see how the feet cubes cancel out? and we get approximately 276.7 divided by 27, about 10.2 bags, but you can't buy a 0.2 of a bag, so you need 11 bags. You always have to round up when you're talking about buying bags of things. Okay? You need 10 bags plus another part of a bag, right? So you need a total of at least 11 bags, because you can't buy like 0.2 of a bag. Do you get that? That is a tough, long, tedious problem, right? But this was a Regents question, okay? Number 13. Put your name on it. This is the last problem. Okay. So, let's see here. Alright, this is the last problem, the last example problem. So Ed works for an environmental protection agency which deals with land areas that have been contaminated by toxic waste. The contaminated soil covers an area of 1.62 acres. Ed must remove the top 18 inches of soil in this area. So essentially what we have is this large rectangular prism. Okay. And it goes like this. Just hold on one second. Alright, so they have to remove 18 inches. Okay? And 1 acre, so if we're talking about the area of 1 acre, okay, is the surface. We're going 18 inches down. So the area of this top piece is 43,560 feet squared. Alright, now we have to remove 18 inches. So we have to remove this area down 18 inches. So let's see how we're going to need to do this. If we're talking about A, what is the area of contaminated soil in square yards? Okay. So 1 square yard equals 9 square feet, right? So we take 43,560 feet squared and we divide it by 9 feet squared. And this is what we get. 43560 divided by 9 is 4840. And that would be yards squared. So that's part A. Part B. What is the total volume of contaminated soil in cubic yards? So remember, volume is B times H. Now this time the 18 inches is my H and my B is this 4840. So volume equals 4840 times, but I got to convert 18 inches into yards. 1 yard is 36 inches. Okay, so if I put 1 yard over 36 inches, I want to know how many yards, x yards, is 18 inches. So I set up this ratio. So I have 36x equals 18. I divide by 36. So x equals 0.5 yards. So I multiply this by 0.5. Okay, you got to be really careful with your units here. So now I have 4840 times 0.5. That gives me 2420 yards cubed. Okay. Whoop. Let me move that up for you. And now I have one more part, C. If each truck can haul 10 cubic yards of soil, how many full truckloads of contaminated soil will Ed be removing? So we have 2420 yards cubed, and we got to divide by 10 yards cubed. So what we get, well, it's 242 242 full truckloads. So that was the answer for C. This was the answer for B. And this was the answer for A. Now, that's the answer for this problem. Now it's for your homework time. Okay? So let's put a line under here. Homework. You have to make up 3 of your own problems and solve them. One must be about lateral edges being congruent and or parallel, and those are like numbers 1 through 4. One must be about finding the volume of a prism, and one must be about finding the surface area of a prism. Note, you must create and solve the problems. Okay? And put that all together with all of this, and that is the end of the first lesson on prisms, pyramids, cylinders, cones, and spheres, and this lesson was all about prisms.